Good afternoon, teachers and my fellow friends. We are Group 1. Our title is Smart Parking, and now we are going to present our report. I'm the group leader Ang Yik Hang, and my members are Junior Wong Tek Kai, Lok Jia Yen, and Tong Ko Wei.
My name is Lok Jia Yen. I am going to present the background of smart parking. Smart parking is a parking approach that combines human innovation and technology. It provides faster and convenient parking of vehicles. The in-ground sensors contain small sensors, camera, and other devices are used to detect the status of the parking lot. Smart parking achieved through the real-time data collection. It's developed in place of IoT-based system that send data through a website or mobile application. Next, I will presenting comparison IoT service. As you can see the comparison heading, the AWS has IoT device management that helps you remote control, track, organize, and update individual devices. While Google Cloud contains a mobile device management that enables the user to set up, authenticate, configure, and control the individual device remotely. On the other hand, Microsoft Azure has their IoT hub that enables device connectivity, management, and communication. In fact, AWS processes the message through rules engine after the message gets through the device gateway. It helps to route them to either the device or cloud AWS service. While Google Cloud could establish connectivity through protocol bridge and processing data in real time through cloud data flow.
Good afternoon. My name is Ang Yik Hang, and now I'm going to present the future trend of smart parking and literature review. In the future, due to the motorizations, demand of parking will grow significantly. Increasing the parking capacity will be a challenge due to the decreasing of available urban space. Besides that, parking management system will be an essence of smart cities to handle all parking-related issues. With advanced technologies, more and more automated process will be provided to assist users to navigate the parking life cycle independently. In short, the ultimate goal of future smart parking will be right parking at the right place with the right price. Next, I'm going to present the literature review. The intelligent car parking service has a 3-layer architecture, which are the sensor layer to detect car lot availability, communication layer to handle the connections between sensor applications, and application layer to handle the user interactions. Next, for optimal resource allocations and reservation, the parking request will be sent to Driver Processing Request Center, and this center will collaborate with Parking Resource Management Center to assign best parking spot to user. The major goal of this system is to allocate and reserve optimal parkings for users. Lastly, the make use of Android application concept is to reduce human intervention by automated the parking process. Users can use the app for sending command to parking control unit and retrieve all parking spot status. After that, user can command the vehicle to park at the assigned parking spot automatically.
Hi everyone, my name is Junior Wong Tek Kai, and today I would like to present the problem statement, proposed solution, and comparison of the NoSQL database. So first of all, the problem statement is about the parking space. Actually, you can know that parking space is a big problem for locals and tourists to find a parking spot within a crowded space like shopping malls, flat suburbs. So drivers need to take up to 10 minutes or more to find an empty parking space in such a large and crowded city. So it could cost a lot of time for them. So we came up with the solution, which is the smart parking application. It is a application that helps drivers to find parking spaces easily without relying on their eyes to look at it. It actually shows the location on their smartphone, so the drivers can locate the parking space easily. And this one is the system architecture. This is our diagram. So moving on to the comparison, we will be compare the 3 different NoSQL database with DynamoDB. So first one in MongoDB. MongoDB is a JSON-like document with optional schemas. It can actually, using the schema validation, it can coordinate and control changes. So MongoDB can create Bison and increase efficiency. So compared to DynamoDB, its difference is that DynamoDB is only available in AWS, while MongoDB is open source and can be used anywhere. So the next one is Cassandra. Cassandra is a free and open source NoSQL database management system designed to handle large data across the server and provide high accessibility with no failure. So the difference between them is that DynamoDB is a key value and document-oriented store. Cassandra is a column-oriented data store. So on the next one is Elasticsearch. It is a search engine based on Lucene library. The difference between them is Elasticsearch is the primary database model. It's basically a search engine. While DynamoDB is primary database model is a document store, key value store in DynamoDB. So another difference is that Elasticsearch has no concept of transaction, while DynamoDB has a conception of transaction satisfying the asset properties. So that's all for my part. Thank you very much.
Hi everyone, my name is Tom Gowei. Today, I would like to present about the comparison of relevant cloud technologies in solving the problem. For the compute service, all of these three platforms can support multiple languages such as Java, Python, and so on. But AWS Lambda has an advantage when compared to other platforms. This is because it provides scalability and fully automated management through concurrent control and event source mapping, while Azure Function has a built-in AI capabilities that can provide future opportunities. Thus, Google Cloud Functions manage dependency through the novelty of extension. Push notification service is used to transfer information from software application to computing device. AWS SNS allow user to send notification messages to single or large number of recipients at the same time. FCM is free for low limit number of messages and use two types of message, which is push message and data message. Push free unlimited cross-platform push notification, and Urban Airship is the oldest and most popular service for sending push notification. For the authentication service, both Connector and Firebase authentication provides email and password authentication such as Facebook, Google, GitHub, and so on. But Connector is easy to manage Connector user through the console. Next, AWS, Azure, and Google all provide API management engine. The unique function of AWS API Gateway is to act as a front end to dynamically call a collection of Lambda function. This allows developers to use feature on demand. Azure API has strong reliability and governance capabilities, and Google enable developers to customize their management experience. Data visualization service, Amazon QuickSight uses its Spice ultra-fast parallel in-memory compute engine platform to provide the data visualization in an efficient manner. Microsoft Power BI provides a variety of connectors, including on-premise data source and other products available in the cloud. Tableau is a major product that is used by enterprise-level companies around the world. It enables business users to study their data in depth without IT integration. So that's all from my part. Thank you.
Good afternoon, my name is Ang Kang, and now I'm going to demo the Connector service that used to authenticate user. First of all, to create an account, we must fill in the registration form and then click on register button. After that, we can refresh our user pool, and we can see that the registration form has been received and the user detail is shown here, but the account status is not confirmed yet. To confirm this account, the user has to go to the email and look for the verification email. Click on this link and the account is verified. Now the account status has become confirmed and the registration is successful.
Hi, me again. I'm Tom Gowei. I would like to demo by using the Postman web to save the user data into the DynamoDB user table. And then after the table has been updated, it will send an SNS email to the subscription email. For the setting part, we have listed each setting step in the user manual in detail, so you can refer on it. Let's check on the DynamoDB table. There are only 5 items in the table. And then we go to the Postman web and insert the link that we copy from the API gateway, and then insert the new user information data and send. So after it's success, we go back to the DynamoDB table and refresh. We have see that the new item has been inserted to the DynamoDB. On the other hand, we will receive an email from the SNS that tells us the DynamoDB table is updated. This is the save user lambda function and triggered by the API gateway, and this is the coding part to save the user and modify user and delete user, and then get the user information. And then for the SNS lambda function is triggered by the DynamoDB, which means any update on the DynamoDB, it will publish a message to the subscription email. That's all from my part. Thank you.
Chaya again. Now, I'm going to demo the IoT service. First of all, we do not implement the real smart parking sensor in our system. So we use the Visual Studio Code to pass the parking lot status data through MQTT to the IoT code. Firstly, we need to subscribe a topic called My Status Sensor. It's used to get the parking lot status data from the device. Now, we want to pass this data to IoT code and run this command to send the data to IoT code. Before I run the command, this is data before I undate the table. Now, run the command. Then, my obstacle sensor will receive the data. After the IoT code gets the data, it will automatically trigger the lambda function called IoT lambda. In this lambda function, will update the data in the DynamoDB table called the parking lot status. Then you can see the table has been updated.
Hello everyone, my name is Junior Motekai, and today I would like to show the AWS demo for the AWS App Synchronize S3 and the quick site. First of all, I would like to show the app string. So first of all, I need to create the API. For here, I already created one. I click in it. So in order to display the message from the DynamoDB, so I'll run this list parking status. After running, I'll get this information, which is log, location, status, time. It should actually show in the DynamoDB. Here is my DynamoDB table. Now on the S3, in order to get a quick site from to generate the bar chart, you need to go to the S3 to create a bucket. First of all, from my as you can see here, I already created two folders. One is export, and the other one is log. So actually, you need to create and run this, and then you can get this manifest file. So after you getting the manifest file, you need to create analysis, new data set, and click S3, and then you copy and paste the manifest file. You just copy from here. After copy, you can do anything you want. You can see this chart I've already created by using that method. So you can actually do anything you want. You can edit based on your preferences. So that's all for my part. Thank you very much.